You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Security Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Documentation in cybersecurity and IT operations refers to the structured records, manuals, diagrams, and written processes that describe how systems are designed, configured, and managed. It captures not only technical details, but also the human and procedural aspects of operations. Documentation translates complex systems into accessible references that guide staff in daily operations, troubleshooting, and long-term planning. Without it, knowledge remains fragmented in individuals' memories, creating risks of inconsistency, downtime, and lost institutional expertise. For learners, documentation represents the backbone of operational clarity, ensuring that security and technology decisions are recorded and reproducible. Accurate documentation supports security, continuity, and audits by providing a reliable source of truth. In terms of security, it ensures configurations are applied consistently and verified against standards. For continuity, documentation makes it possible for teams to recover quickly when staff changes occur or when incidents disrupt systems. During audits, documentation demonstrates compliance with policies and regulations, showing that organizations not only implement controls but also track them formally. Accurate records reduce uncertainty and build confidence that processes are both deliberate and defensible. In regulated industries, thorough documentation can be the difference between passing and failing an audit. Typical documentation artifacts include network diagrams, which illustrate system interconnections, runbooks, which outline step-by-step operational tasks, standard operating procedures, SOPs, which define repeatable practices, and inventories, which list hardware, software, and assets in use. Each artifact serves a distinct purpose. Diagrams provide visual clarity, runbooks support incident response, SOPs guide daily consistency, and inventories ensure assets are tracked and patched. Together, these artifacts form a library of knowledge that supports efficiency, accountability, and resilience. For learners, understanding these categories helps them see how documentation connects to practical operations. Version control adds another layer of discipline by managing how documentation and configuration records evolve. It ensures that changes are tracked, stored, and recoverable over time. With version control, organizations avoid the chaos of multiple conflicting documents, instead maintaining a structured record of revisions. This system allows teams to roll back to earlier states when errors occur, compare historical versions to understand changes, and collaborate safely across teams. Version control is not just for developers, it applies equally to IT operations, configuration baselines, and procedural records, ensuring all changes are deliberate and traceable. Source control systems, such as Git, provide conceptual features like commits, branches, and merges. A commit records a set of changes, creating a permanent history entry. Branches allow experimentation or alternative development paths without altering the main version, while merges bring those changes back into the stable branch once reviewed. These concepts help teams collaborate without overwriting each other's work. Even without using code repositories directly, understanding these principles helps IT professionals manage configuration documents, ensuring both flexibility and stability in their workflows. There is an important difference between document versioning and code versioning. Document versioning focuses on maintaining clarity, readability, and traceability of manuals, policies, or procedures, where collaboration is often slower and more structured. Code versioning, by contrast, emphasizes frequent, iterative commits, where merging and integration occur rapidly. Document versioning might track major revisions with dates and author names, while code repositories handle fine-grained technical changes. Both approaches, however, serve the same purpose: to prevent confusion, allow controlled evolution, and provide a history of modifications that supports accountability. Changelogs and revision histories are essential for traceability. A changelog records updates in chronological order, explaining what was altered, when, and why. Revision history serves as a roadmap for auditors and investigators, showing how a configuration or process has evolved over time. Without these records, organizations struggle to explain why systems look the way they do, or when deviations occurred. Traceability is more than administrative. It is a security requirement, ensuring that changes are transparent and subject to review. Learners should see logs and histories as the institutional memory of IT systems. Naming conventions and metadata practices make documentation searchable and usable. Clear file names, version identifiers, and descriptive metadata help teams quickly locate the right records when time is critical. For example, a disaster recovery runbook labeled with date, owner, and system scope is far easier to use than a vaguely named file. Metadata such as tags or classification labels further enhances searchability. These practices may seem small, but they prevent costly delays during incidents and audits. For learners, naming and metadata underscore how usability is a critical part of effective documentation. Controlled access and classification of documentation are necessary to protect sensitive details. Configuration records, network diagrams, or administrative runbooks may reveal weaknesses that attackers could exploit. By classifying documentation appropriately, such as internal, confidential, or restricted organizations, ensure only authorized individuals can view them. Access should be logged and monitored, reducing the risk of insider misuse. For learners, this demonstrates that documentation is not just about transparency. It is also about safeguarding knowledge that could be weaponized if exposed. Storing documentation in a secure, backed-up location ensures its availability and reliability. Just as data requires redundancy and backup, documentation must also be protected against loss or corruption. Central repositories, cloud-based collaboration tools, or secured internal wikis serve as reliable storage solutions. Backups ensure that even if systems fail or files are deleted, documentation remains recoverable. Learners should see that documentation is itself a critical asset. It must be treated with the same rigor as the systems it describes. Documentation must be treated as a living asset that evolves alongside systems. Technology, threats, and business requirements change rapidly, and documentation must keep pace. Outdated manuals or diagrams are as dangerous as having no documentation at all, as they mislead teams during incidents or audits. Regular reviews and updates ensure that documentation reflects reality, maintaining its usefulness as both a guide and a compliance artifact. For learners, the key message is that documentation is never finished. It is a continuous responsibility that underpins security and operational success. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Branching strategies, at a conceptual level, allow teams to experiment safely without disturbing stable documentation or configuration baselines. A branch is essentially a copy of the main record where changes can be tested, reviewed, and refined. Once the branch proves successful, it can be merged back into the main version. This approach prevents half-finished or risky updates from disrupting daily operations. For learners, branching illustrates how teams can balance innovation with stability, ensuring experimentation and improvement occur without jeopardizing core processes. Tagging or release markers are used to identify stable versions of documents or configurations that can be trusted as reference points. A tag might mark a policy revision approved for compliance, or a configuration snapshot verified as secure. These markers allow organizations to roll back to known good states if later versions cause problems. Tagging is particularly useful in audits and incident response, where investigators need to know exactly which version of a procedure or configuration was in effect at a specific time. It transforms documentation from a static record into a navigable timeline. Review and approval workflows are critical before publishing documentation or configuration changes. Just as technical changes require oversight, documentation updates also need validation to ensure accuracy and alignment with policies. Peer reviews, manager sign-offs, and cross-team collaboration reduce errors and ensure clarity. This step ensures that documents are not only technically correct but also understandable to those who must use them in practice. For learners, this reinforces the principle that documentation is a shared responsibility, requiring both technical precision and organizational oversight. Automated pipelines can validate configuration documents before deployment. These systems check for syntax errors, compliance with established baselines, and potential security issues. For example, infrastructure as code scripts may be run through automated validators to ensure they meet organizational standards. Automation reduces the risk of human error, speeds up the review process, and ensures consistency. For learners, pipelines highlight how documentation and code increasingly intersect in modern IT, where configurations are treated as living documents subject to the same rigor as application development. Rollback procedures and backout steps must be documented clearly to support resilience. If a change goes wrong, administrators should be able to follow documented steps to return systems to their prior state quickly. These instructions prevent improvisation under pressure, where mistakes are most likely. Documented rollback plans provide assurance to approvers and auditors that risks have been considered and contingencies prepared. For learners, this underscores the idea that documentation is not only about what to do when things go right, but also about what to do when they go wrong. Traceability connects requirements, design documents, and implementation artifacts, ensuring that every decision and change can be tracked from origin to execution. This linkage provides visibility across the lifecycle, showing how business goals translated into policies, which then shaped technical configurations. Traceability supports accountability by allowing auditors and investigators to verify that changes were intentional, justified, and aligned with organizational objectives. It also aids troubleshooting by mapping issues back to their roots in requirements or design. For learners, this highlights documentation as the connective tissue of governance and operations. Retention policies and archival strategies manage how long documentation and version histories are kept. Some industries require records to be maintained for years to satisfy legal or regulatory obligations. Archival ensures older versions remain available for reference while keeping active repositories uncluttered. Retention policies balance the need for accountability with storage efficiency, ensuring that records are available when needed but not retained indefinitely without purpose. For learners, this reinforces the importance of lifecycle management and documentation practices. Auditability is one of the strongest benefits of version control. By maintaining histories of documents and configurations, organizations can demonstrate exactly what was changed, when, and by whom. This capability supports both internal investigations and external audits, proving compliance with regulations and accountability in operations. Without version histories, organizations may struggle to defend decisions or demonstrate control. For learners, this shows how version control transforms documentation into evidence, reinforcing trust and compliance in security programs. Handling secrets and sensitive details in documentation requires careful control. Passwords, encryption keys, and detailed network diagrams should never be left in unsecured documents. Instead, sensitive information must be masked, referenced through secure vaults, or stored in protected repositories with restricted access. Mishandled documentation can create vulnerabilities as damaging as a technical flaw. For learners, this underscores the point that documentation is itself a security target and must be protected accordingly. User-friendly formats and indexing make documentation practical for everyday use. Documents that are overly complex, unsearchable, or poorly organized discourage use, undermining their purpose. By structuring information clearly, using indexes or digital search tools, and presenting content in accessible language, organizations ensure that documentation serves its intended audience. The most secure or detailed record is useless if it cannot be applied under real-world conditions, such as during an outage or audit. Accessibility ensures documentation remains a living, useful asset. Metrics for documentation health include freshness, completeness, and accuracy. Freshness measures whether documentation is current, completeness ensures that it covers all necessary areas, and accuracy validates that the details match reality. Regular reviews against these metrics keep documentation effective and relevant. By applying measurable standards, organizations prevent documentation from drifting into obsolescence. For learners, these metrics demonstrate that documentation must be maintained with the same rigor as systems and controls, ensuring it remains a trusted source of truth. In summary, documentation and version control form the foundation for repeatable and auditable security practices. Documentation captures the knowledge needed to maintain systems, while version control ensures that changes are tracked, reviewed, and recoverable. Together, they provide visibility, accountability, and resilience, supporting both day-to-day operations and long-term compliance. For learners, the message is clear. In cybersecurity, documentation is not paperwork. It is a security control in its own right, and version control ensures it remains trustworthy, accessible, and authoritative. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.